I'd like to introduce James, M1DST. And I know James because we're members of the same radio club. Now, how to describe James? A practical innovator that likes experimenting, and if he sees something he thinks there's a hole in a market that he can't get or might like, he builds it. Is that fair? Yeah, okay. So I'm going to say no more than that, other than that's the basis on which he's working. So James, M1DST, about M1N-the-Middle. Thank you, James.
Okay. Everyone hear me? Yeah. There we go. Okay. Can you hear me now? Great. Let's start again. Hello, friends. Hello. I call you friends, but most of you probably don't know who I am, so I'll just share a few seconds about me. I've been licensed almost 20 years as M1DST. I also hold the short contest call M1N. As Tony said, I'm a member of the Swindon Radio Club. I enjoy contesting. I write software all day, every day for a living. Don't collect QSL cards, and I know enough CW to get me into trouble, so I typically avoid that and stick to contests and check it and catching DX. I'm not sure how these slides will... Oh, they are fitting on. Great. Okay. So I am an Elecraft fan. I've got a number of Elecraft radios, a K3, a K3S, and a KX3, just so I can get a feel for the room. How many people have got some kind of K3? Brilliant. Okay. And yeah. And out of the people who've got their hands up, how many people built them themselves? Great, a reasonable number. Okay. Anybody make things in the room with microprocessors, electronics? I'm not talking about valves or anything, but anybody? Okay. Okay, good. So we got a few people in there. What about surface mount? Anyone happy with surface mount? Okay, good. All right. So about 50-50, but we'll see how it goes. Okay. So I like Elecraft radios. You obviously like them as well, but nothing is perfect in this world. I came across this on Twitter the other day. I'm a fond Twitter user, and I thought it was quite nice, so I thought I'd share it with you. Don't build something because you want to sell it. Build something because you want to buy it and you can't. I thought that was quite a nice quote. So most of the projects that I work on are solving problems. Even if those problems have been solved by somebody else, because as hands we like reinventing the wheel. So some of you who have actually built the K3 probably recognize exactly what that is. That's the power pole input for the DC. That's when I fell in love with power poles, and I power poled everything in sight. The problem that then caused me was I had no way of distributing the DC at power poles without buying something expensive like a West Mountain radio, rig runner. So I started putting together kits, basically cloning the functionality of West Mountain radio rig runners, plus also this one up here, which is a box I use with my KX3 for reducing the voltage coming from a LiPo battery until it falls to the appropriate level, in which case I can then switch the switch. I've sold several hundreds of these as kits around the world. So the next problem I had was I put a 10 megahertz reference in the K3. So I bought one of these, which is a Trimble Thunderbolt. Anyone have one? Okay, 2 people. Quite old now. Used to be quite cheap. Now they're very expensive if you can find them on eBay. But that's what I use for locking all of my equipment together. So that caused me another problem. I've got more than one radio. I've got various other bits of kit which I can lock to 10 megahertz. So I built one of these, which is basically, it's difficult to see on this one, so maybe you want to have a look on those ones. But basically it's a 19-inch rack case with a Thunderbolt here, a power supply, a distribution amp giving me loads and loads of outputs at 10 megahertz. But the problem that I had was I never knew whether the GPS was in lock or what state it was in, or maybe I wanted to send it to various commands. The typical way of doing this is to use a PC, connect it to a piece of software, and you can see that. But that's not always convenient, so I built a monitor which sits here. This is basically a microprocessor, a various board, and a 4x20 LCD. I've now sold 200 of these projects around the world. That's what one of the screens looked like. Gives you the output in UTC. You can see this is quite an old photo, this particular one. And you've got various other screens. The other nice feature in this one was I built an NTP server in it as well, all on this little microprocessor board. Other people like them as well, including this guy Charles, which I love his call sign, WA3UTC. He started buying my kits and then commercially putting them together into lovely looking boxes and selling them. If you fancy more information about those, just have a look at my website a little bit later on. What's the latest problem that I have with the K3? Well, that's control. And I think we have this problem with all radios, so we won't just pick on the K3. It's to me, it's well designed ergonomically. It's a nice radio. Things are laid out, but there's always more that you want to do in terms of using the radio. So I'm a WinTest user, and if any of you have been to some of the other talks today, you'll find that people have been pushing very heavily all of the macros and the keyboard bindings that you can do in all these pieces of software. That's what I do when I'm at home. The downside of that is you are heavily reliant on your particular station. So when I visit various other contest sites, such as the Swindon Radio Club, they use M1M, and they're using different radios, and kind of all my muscle memory falls to pieces because I no longer know how to use the software, and certain keystrokes don't work anymore, or it's not always easy to remember how things work. And the key thing is it requires a computer, and sometimes if you're operating away, you may not have a computer, you might have a tablet or something that's a little bit lighter weight than a full PC. So with a K3, you've got several options. Out of the box, you've got these memory, or these M buttons at the top here, and you've also got a couple of extra push and hold buttons here. Well, to me, these ones at the top aren't available because I've got the voice keyer installed, so that leaves me with these two buttons here. It's not really enough for what I'm looking for. But then Elecraft came out with one of these, which is the Keypad. It's very nice. It's got a nice rotary encoder in there, a number of buttons which give you, I think, I've never actually touched one, but I think up to 16 commands can be triggered from this with long push and short pushes. The downside of that, it costs 300 quid. I mean, that's a lot of money to spend on a few buttons and a rotary encoder. It also reminded me very much of this prototype that I put together in 2014 of an external knob. You can't really see it in this picture, but this is actually an Elecraft K3 knob on the front of the box that I bought from Elecraft and discussed this project with back in 2014. This is what it cost me, $24 for the knob and the little rubber surround. So what's inside this Keypad that can make it so expensive? Well, to start with, they didn't use a very cheap encoder like I started with in that prototype. They use one of these Bourne's encoders. It costs about 35 quid from Mauser. The unfortunate thing is it's a non-stocked item and you need to buy it in bulk. So that's a bit of a problem. Elecraft would sell that to you, though, if you wanted one. So I looked around on eBay and I found these, just cheap Chinese encoders. I think I may have brought one today if someone wants to see it at the end that I've dismantled so you can see what's inside it. I brought a couple of them to play with, a 100 count and a 400 count. They're optical encoders, they're very nice. Cost about 7 quid. The box I was using at the time was about 6 quid, so in terms of all the electronics and things that I put inside it, I had a knob for about 40 quid. Which to me was a nice price. And then hunting around the forums one day, I came across an idea from NK7Z Dave, who had purchased one of these control pads, about that size, It's just a, in this case it's a programmable keypad, but it doesn't need to actually be programmable. I've got them programmed with just A through Z, 0 through 9 and a few other bits and pieces on them. So it's just a nice form factor, reasonably priced, but the key thing is you can lift the keycaps off, print out something on your printer and put it down. So how does that work? Well, it's USB, so you can't plug it into the K3 itself. So you'd need to buy a P3. Who's got a P3? Great, lots of you. Keep your hands up. Out of you, how many have also got the SVGA add-on board? Oh, okay, that's about 1 to 1. I didn't expect that, but most people, it seems, don't have the SVGA board. But that's how you can come up with this interface of using this keyboard here. You can plug it into the P3, store some commands in it, and basically send the commands via the keypad directly to the radio. The downside of that, it'll cost you $1,000, which is quite expensive to make a cheap keyboard work. So we've spent a fortune on our radio. We've now bought a expensive knob and a $1,000 on a pan adapter. So this would be the block diagram, as it were. The K-pod at the top plugs into the K3, P3 connects to the K3 and a PC and a keyboard. So that's the block diagram. It's very expensive, as we've learned. So now I have a new problem. Elecraft have built a commercial knob. Why would somebody want something from me or to potentially do something themselves? Not as many people have a P3 with the SVGA option. So I set about trying to work out, could I do something to make this whole process cheaper, make it more expandable. So I started putting some requirements together. I wanted it to be easy to build, modify and hack. It had to be configurable. We're all cheap, so it had to be inexpensive. It needed to be easy to install so we could take it from place to place. Had to have an optional knob. Not everyone's going to want one. Had to have an optional keyboard. Not everyone's going to want one of those. Needed to be open source in every way. I mean, that's key for me. It needed to be open source hardware, software, and all of the CADing need to be open source as well. But it also had to have the Elecraft philosophy of upgradable and future-proof. So what would that look like? It would look like something like this. The K3 at the top. If you have a P3, great. If you have a PC, great. If you have a knob, great. If you have a keypad, you basically have the ability to add any kind of functionality that you want to this box, which sits here. Why is it called M1N-the-Middle? Well, anyone who's security focused will know that there's a thing called a man-in-the-middle attack, and sometimes it's shortened to that, and it just so happened to me it looked a little bit like M1N, and it sat in the middle, so M1N-the-Middle. That's where the name came from. So how did the project start? Well, it started just with a cheap Uno and a couple of things that I had together, hacked around, a couple of shields, and an EEPROM. One of the things that I realized fairly quickly is EEPROMs are a pain in the backside to use. Well, for me they were, if you're wanting to store structured data in them. The odd piece of information is fine, but I was struggling to store structured information in an EEPROM. The other thing I learned is USB doesn't just mean USB. There's two types of USB, USB client and USB host. They are not the same. It's easy to be a client, which is a keyboard, essentially. It's not easy to be a PC, effectively, USB host. Generally, you require some kind of external hardware to make that work. You can't just take an Arduino and suddenly start talking to these bits of equipment. And then scope creep crept in, as it always does. Hunting around for other cool things about the K3, I found this photo from G4FRE. Is he in the room? There he is. You recognise that photo? Good, okay. So he had the idea of band decoding via RS-232. And he published his idea on his website. And I thought, well, there's nothing in that I haven't already got access to in my design, so I'll steal that idea and I'll put that in mine as well. But it gave me a problem. I didn't have enough I/O. So I'd moved from an Uno to a Leonardo. but I still needed more. So I moved again and quickly moved to a Mega. The whole time I was trying to stay as cheap as possible. When I created that Thunderbolt monitor, for me, I don't code on a day-to-day basis in C++. I'm a C# developer. So I had selected a Arduino board, which is just like the Arduino in terms of footprint, and I was extremely productive. The downside of that is, although I'm giving all this stuff away for free, you also get the advice, it's not as cheap as an Arduino, and people want you to start again, even though they're not actually having to pay for any of this stuff. So I was trying to stay as cheap as possible, use an Arduino Mega. Show you what the difference in the Mega is. Well, the good thing about that is I've now got 4 real UARTs, so I'm not having to rely on software serial anymore, but I've now got plenty of I/O. Over here we've got 54 I/O ports, even though the CPU speed is still about the same. But I was struggling in terms of the amount of effort I was putting in. I was certainly not as productive as I had been on the previous boards. So I gave up and I bought one of these boards from GHI Electronics, which is a Panda 3. I mean, look at the processor speed on that. It's 180 megahertz of processing speed. It's still Arduino pinout compatible, but it now runs my favorite programming language. The key thing is it's also got USB host built in. It supports debugging, but it's also now got this SD card reader, so no more EEPROM for me. And plenty of I/O. So I was now extremely productive, writing code faster than I'd written it before. I was now mocking up PCB shields to sit on the top of it with prototyping space as well for anybody who would like to add additional functionality. All of the configuration was stored in JSON files on the SD card, so it meant it was now portable between other people's installations. And I'd written all of the libraries for the hardware I was interfacing with that wasn't available. It's not an Arduino, so there's not thousands of people using these boards. So sometimes libraries aren't always available for this. And then fail. I'd developed very logical blocks, essentially, which I'd been testing independently. So I got the knob working, and I got all of the band switching working, and I got all of the other various functionality working. Put it all together, and it didn't work properly. There wasn't the performance I was expecting. To start with, we had poor RS-232 performance at high rotations of the knob. And when I mean high rotations, I'm not just talking about spinning it fast. I'm talking about electric drill kind of speed, because someone's going to try it. So I want to make sure this thing doesn't fail. So that meant I needed to start looking at other options of reducing the amount of traffic on the RS-232 bus. Seemed to have got that resolved. The next problem was those GHI boards were unreliable on detecting whether a USB device was plugged in, which meant sometimes on initial power-up you needed to reset them. The other problem that I found was if you were just doing something on USB host, it was absolutely fine. But if you want to do anything else while it's doing something with the USB host, that wasn't fine, and the performance was just unusable. So I needed to give up with that and go back to an Arduino and just scrap everything that had been done, which was a shame. But by then I'd found this Arduino Due. It was still running a 3.3 operating voltage, the same as the GHI board, so most of the schematics that I'd developed for the previous board was okay, because I could just change the pin locations and such like. Plenty of I/O, plenty of RAM, plenty of flash, loads of UARTs, 2 USBs. It had USB host support built in. Great. That's what an Arduino Due looks like. For anybody who hasn't seen it, it looks very similar to the Arduino Mega. Unfortunately, I found out recently it's been retired. But that doesn't matter, because our Chinese friends have been mass producing them, and they are super cheap and available in large quantities on eBay. So they're about £10.50 on eBay, which is about 4 times cheaper than that GHI board that I showed you previously. Okay, so I'd started working on porting all of that functionality back over, and I got USB host working for the keyboard. The performance was terrible again, but this time it was based on me using somebody else's library. Managed to fix that. The performance is now okay, so that's good. So that was the big hurdle I had. So what do we actually have now? Well, we have a new PCB with various connectors on it. We have a mix of SMD components. I'm afraid they're 0603, so they're quite small components, but I fancied another challenge. There's loads of through-hole pin headers on there, and a network interface port and a few other bits and pieces. I'm using all of the I2C interfaces and SPI, stuff like that. And basically what we're doing here is we are buffering information between the optional PC that you may bring along and also the radio. So all of the DTR, DTS and someone help me out, I didn't write them down, but you know what I mean. All of the various switching lines are also passed directly through, so you're not losing any of those switching lines should you require them. So this is a fully built version. Just for scale, you can see how big they are. This is a breakout board, which gets plugged into the main board, and that breakout board gets installed in another piece of hardware, which I'll show you in a second. That's kind of a bodged up version of it, fully built, using bits out of an old PC and a screen. So we've now got an SD card reader on the device. We've got tons and tons of outputs and a screen. So that little breakout board that we saw is used as part of the external knob that you saw. So this is the current version of the knob that I've been playing with. That sounded dodgy, didn't it? It's a 3D printed case. It's actually a 3D printed knob as well. It's got an external user-defined button on it and a user-defined LED of things of your choice. We'll talk about those a little bit later on. So what does it actually do? What's its functionality? We'll talk about the knob first. It's using a 100 ppr optical encoder, which I do all the level shifting down to 3.3 volts because that's too low for the operating voltage of the encoder itself. So that 100 ppr is exactly the same as in the K3, not the same encoder itself, but in terms of the PPR. Because I'm using a DUE, I'm able to use one of the other features of the DUE itself, which is hardware quadrature decoding, which is really nice because I'm not having to use all of the interrupts and all of the other typical ways of decoding that signal. One of the ways I've been looking at reducing the contention on the CAT bus is basically looking at velocity. Anyone with a IC 7300 or similar radio will know that the faster you turn the knob, the faster the encoding steps are. So I've built support in for that. On the knob itself, it's got an OLED screen which shows currently shows the frequency. There's 2 lines of custom data available there. The button is able to be completely configured to do whatever, trigger whatever function it is that you've got stored within the main box. So it could be switching between VFO-A and VFO-B or PTT or any other custom function you can think about. The LED again is same as the button. You can configure it to do pretty much what you want. It's just an LED that you can switch on and off as you like. And it just connects to the main M1N-the-Middle box just using a standard network cable. So what does the main box do? Well, at the moment I'm experimenting between a small OLED screen and a 4x20 LCD. 4x20 LCD seems to be winning in terms of performance. There seems to be more of an overhead writing to the OLED screen. It's got 16 outputs using 2 ULN 2803s, which mean you are able to switch inductive loads up to 50 volts, half an amp. You've got 16 digital outputs available to you, 4 configurable LEDs, 4 level shifted serial ports with DTR, DTS and RTS pass through from the PC should you be requiring them, an SD card reader, a load of unused I/O at this point for various other features, and we can use the USB to serial that's built into the Arduino as well, should we wish to. It also supports USB hosts in terms of the keyboard, the ability to store the configuration on the SD card so you can move it between installations. An experimental build at the moment with interpreted macros on it, allowing you to control other functions, not just things in the K3 or the P3. It's got a dedicated PTT input, and it actively polls the frequency of the rig if the watchdog fails. So there's basically a watchdog running in this box, and it's looking for the last time that the PC requested the information from the rig. And if it hasn't been patted for a while, then it actively takes over and starts polling the radio itself. Here's the kicker. It's not actually limited to helicraft rigs at all. I mean, it's just standard RS-232 and CAT commands. There's no reason why it can't be used on any modern radio that uses standard serial CAT commands. So what else? What else does it do? What else have I been thinking about? Well, is anyone a budding DJ? Probably not in the room, but okay, we've got one. So if you are, you may well recognize bits of kit like that. They look, here's an example. I've got both of those, but here's an example of one of them because it was the smallest one. This is a USB device. It's got soft touch keys, very similar to matrix to this. It's got faders and rotary encoders and all kinds of interesting things on it. And this transmits a stream of MIDI straight out the back of the USB. Exactly the same. We have another control surface over here. This is quite an old one, so it's extremely cheap on eBay. But we've got a couple of look like turntables, and we've got faders and all kinds of stuff. Nothing on here is analog. It's all just squirting MIDI out as you make any of the changes. So imagine being able to plug one of those into one of these boxes and map any of those functions there to any function on your, not only on your radio, but in terms of anything that you can control in your shack using some kind of I/O. So imagine being able to not use the knob, for example, and maybe you've got VFO A here and VFO B here, or radio A and radio B, and maybe the RIT over here. It's endless. You have the ability to map whatever functions you like to the radio. So we have a number of use cases I've come up with. It's just some of them. I'm sure other people can have ideas. We've got band decoding can be done now because we know the active frequency at any one point. And if you're a VHF guy, you could route the PTT to a various transverter maybe, or you could do any other kind of antenna routing at HF. You could have a K3 with 2 receivers and 2 operators during a contest. Maybe one's a new operator. You could give them access to your second receiver, and they have access to this knob, and potentially route all of that RS-232 traffic to another PC and allow them to fill up the cluster for you. You could just use the knob rather than having to reach forward. You can have a knob like this, which is all 3D printed, just close to the keyboard and move it around. Maybe you don't want one of those. Maybe you just want a keyboard. It doesn't have to be one of these. It can be a standard PC keyboard, of course, and you could just stick stickers on it. Maybe you want to keep a second radio on the same frequency as your working frequency, like a SDR, for example. Maybe it could be used remotely. What I use it for on some of these functions here is switching configuration. So I have a couple of different headsets plugged into different ports, and they've each got different mic settings. And a switch of a button there, it can completely change the headset that's connected to the radio. So everything can stay connected, and all of the mic levels change, all of the config, all that kind of thing works as well. So a couple of ideas I've had but not yet put into place. The ability to actually add a mouse cursor to some extent to the P3 to move the cursor around for almost click and change frequency. There seems to be enough CAT commands in there to be able to move the cursor around. So imagine, and when I say move the cursor, I don't mean a physical mouse pointer. I literally just mean dragging the cursor across the screen. The other thing you could do is emulate a PC, emulate a keyboard connecting to your main operating PC. So maybe when you fire a few keyboard buttons over here, it changes the operator on your contest logging tool of choice. There's no reason why you can't connect a rotator to it. Somebody asked me the other day how far this was away from being an SO2R box. Well, anyone who's seen my GitHub repository sees that I have the Arduino code for the OTRSP Arduino source hosted in there, and I'm managing the repo for that at the moment. So actually, it's very easy to add that. We could add an additional shield onto the top with just the switching components and audio mixing, and that would be a nice way to keep the two projects separate but actually make them work together. Just a little bit more fun. This probably won't make it into the version I push. Does anyone recognize what that is? So if you get an external knob and you add it with no LED screen, you can have Pong. And if you boot the box holding down the button on the side, you get a fun game of Pong for when contests are a bit boring. So enclosures, well, they're difficult. I'd started just using one of these Hammond Engineering metal boxes and drilling those out to produce these things. I got to in the end to deciding that there wasn't a good solution going forward because drilling templates can slip and people aren't always comfortable doing that. So I started looking at CADing them up. And then I thought, well, I may as well CAD a knob up while I'm here as well, because although $20 is $25, whatever it was, is quite cheap for a knob, there are going to be some people out there who want to print their own for 99 pence or whatever. So I CADed up a knob, I CADed up a box for the enclosure and the encoders and the breakout boards, etc., and started putting them together. And then I bought a 3D printer and learnt how all that worked, and started producing these boxes to test. So here's kind of one not fully built yet, but here's an example of a white one that's fully built. If someone wants to have a look at the end with the breakout board inside and the buttons and the LEDs, and you can feel how smooth the encoder is. And we've kind of come to the end of that, but I wanted to share one more thing with you just to make you laugh. It's a bit of a gimmick. Anyone know what one of those is? That's right. It's when you're working in a contest and you're a bit thirsty, and you call on your butler Jeeves, and he comes in and he brings you a nice cup of tea. Well, not really. It's for multipliers. Typically, if you work a multiplier, you'll reach across and you'll push the bell. Well, reaching across and pushing the bell is too much work. It's 2017, so I've automated this with Jeeves. And Jeeves essentially listens on the network for UDP packets coming from N1M in this case. I tried doing it with WinTest, but the contents of the packets didn't have enough detail to be able to allow me to do that, unfortunately. And it sends commands to a string of WS2812 LEDs, which we actually use in the shack for 12-volt lighting. And each time somebody in the contest works a mult or a QSA, it rings the bell. It doesn't have to be used in the shack, of course. If you have a mess tent and people want to know how the contest is going, how that novice operator is working, it's Wi-Fi, so it can be installed remotely. It's 100% automated, fun, and a bit of a gimmick. So what does it look like inside? It's dead simple. It's just a relay and a small ESP style Arduino connected to Wi-Fi. How does it work, or what does it actually do? Well, I'll just show you. I'll knock this up on the kitchen table just to give you a demo. Rob, I think if you've got the audio turned on, I can probably demo this somehow. Where's my mouse cursor? There we are. So this bit's optional, you don't have to enable that, but every time you work a QSO, you just get a nice silent scrolling one. If you work mult 1, you get a bell and you get a red light. If you work two mults, you get a blue light. If you work a third style mult, you get a green light. If you work a double mult, yay! And if you somehow work all 3 mults, yes! It lights up, it's Christmas time. And that's just something small like that. It's just a little bit of fun in case anyone comes into the shack and wants to do it. The future plans for that is it's already picking up all of the broadcasts, so we already know the current score, how many QSOs are on there. So the plan is to add web server support for anyone local, just to be able to connect into it and see what the current score is or the current rate, etc. We've blown through this a bit quicker than I planned, but that's the end. If you've got any technical questions about how any of this works, I'm around all weekend, so just come and have a chat. If you want to have a look at the board or some of the examples, I've brought some 3D printed bits and pieces and some PCBs if you want to have a look at them. But that's me done.
Okay, thanks very much, James. I told you he was an ideas man, didn't I? Now, I think, with those of you who were at the last talk about WRTC, I think some of those ought to be going to WRTC on every tent. I think we ought to be doing that. Yeah, absolutely brilliant, James. This is what we get at Radio Club. He comes in, and off he goes, and I'm going, it's going here and here and here. I have no idea what he's talking about, but he knows what it does, as some of the others. Any questions at all?